Welcome to this explainer. Okay, today we're exploring a fascinating, real-life mystery of human biology. It's the kind of thing that honestly sounds like it belongs in a superhero comic book, but it actually happens in the real world to completely ordinary people in the blink of an eye. We are talking about a phenomenon known as hysterical strength. Have you ever wondered if you have hidden physical reserves you've just never tapped into? Well, spoiler alert, your body is hiding a profound secret from you. Let's dive in. Take this unbelievable true story of a 16-year-old kid named Zach Clark. So Zach was a high school football player who could deadlift around 400 pounds. Strong? Sure. But when he heard his neighbor literally crying out for help because her husband was pinned underneath a crushed car, Zach didn't just lift 400 pounds. He rushed right over and heaved the entire front end of that car up just long enough to save the man's life. He didn't have time to warm up. He wasn't thinking about his lifting form. He just acted. And just to really put the massive physical stakes of that kind of event into perspective, think about this number for a second: 3,500 pounds. That is the sheer weight of your average mid-sized car, like the Chevy Impala that a woman named Angela Cavallo miraculously lifted back in 1982 to save her teenage son who was trapped underneath it. 3,500 pounds. To put that in context, the absolute world record for a deadlift by a massive, highly trained professional strongman is just over 1,100 pounds. So how on earth is a mother, or a 16-year-old boy, lifting something that heavy? Well, this brings us to exactly what we're dealing with today. Hysterical strength is basically a temporary display of extreme physical power way beyond your normal capacity, typically triggered in life or death emergencies. Now, it's absolutely crucial to understand right from the jump that this isn't magic. There's no supernatural superpower at play here. It's a deeply embedded, evolutionary survival adaptation. Think of it like a biological emergency protocol that your body initiates when it suddenly realizes there are only two options left: fight or die. Here's a crazy fact. On a normal day, even when you feel like you're pushing yourself to the absolute limit at the gym, you're really only recruiting about 60% of your muscle mass's actual capacity. Even elite Olympic-level athletes, people who literally dedicate their entire lives to training their nervous systems, they only tap into about 80% of their physiological maximum. Which, begs the million-dollar question: where is the rest of our strength hiding, and why is it locked away from us? Part 1, the brakes, the central governor. To understand how we access that hidden strength, we first have to look at what's stopping us from using it right now. It really all comes down to the central governor theory, which was originally proposed by Professor Tim Noakes. He explains that fatigue isn't just a physical event in your muscles, it's actually a protective mechanism generated by your subconscious. When you're running or lifting heavy groceries and your muscles start to burn and you feel like you just can't take another step, that isn't actually your muscles failing. That's your brain interpreting the rising effort and deciding, nope, this is unsafe, we need to stop. Your brain acts as a central governor to prevent catastrophic biological failure. It is actively withholding your strength to keep you from accidentally destroying yourself. But how does the brain know when to hit the brakes? It relies on physical sensors. Enter the Golgi tendon organ. It's this tiny sensory receptor located right where your muscle fibers merge into your tendons. You can kind of think of it as the body's built-in mechanical tension sensor. Whenever your muscle generates force, this little organ gets squeezed and sends a signal zipping up to your spinal cord, constantly reporting on exactly how much tension is being put on the tendon. Now, when that tension gets way too high, like when there's a serious risk that your muscle might literally rip the tendon clean off the bone, the Golgi tendon organ triggers something called the autogenic inhibition reflex. It fires an overriding signal straight to the spine that essentially just cuts the power. It forces the muscle to instantly relax. And under normal, everyday circumstances, this mechanism is totally non-negotiable. It's there to protect us from tearing our own bodies apart. Part 2, the override, the amygdala hijack. So how do we get past those brakes? Let's walk through the exact physiological sequence of this override, step by step. First, a massive threat is perceived. A car falls, a wild animal attacks, whatever it is. Instantly, the brain's threat detector, the amygdala, lights up. It sounds a huge biological alarm, causing your adrenal glands to just dump adrenaline directly into your bloodstream. But here is the truly fascinating part. This massive chemical surge temporarily bypasses your frontal lobes. That's the rational, thinking, logical part of your brain. Your conscious mind is literally locked out of the control room. Your body just takes over completely, running purely on primal survival programming. Part 3, the engine, muscular response. Once that override code is initiated, what is actually happening at the cellular level inside your muscles? That adrenaline dump fundamentally changes how your biology operates in just a matter of milliseconds. Your heart rate dramatically spikes to pump oxygen, blood is forcefully redirected away from your digestive system and shoved straight into your skeletal muscles. Your liver rapidly converts stored glycogen into glucose, which floods your system with high-octane rocket fuel, and crucially, a massive wave of endorphins rushes in to completely suppress your perception of pain. You literally do not feel the physical toll of what you're doing in that moment. Zooming all the way down to the microscopic level, you have these proteins called myosin and actin that are doing the actual heavy lifting. Because those descending neural signals from the brainstem have completely blocked the Golgi tendon's inhibitory brakes, these myosin crossbridges can lock and pull the actin filaments at absolute maximum capacity. It's like a cellular tug-of-war where everyone pulls at once. Every single available motor unit is firing simultaneously. You are achieving a level of muscular recruitment that is physiologically impossible under any normal conscious circumstance. Part 4. The cost. Why homeostasis rules. Which brings up a great question. If we have this power, why can't we safely walk around in a constant state of superhuman strength? Well, it all comes down to the cost. The consequences of overriding your central governor are frankly severe. People who experience hysterical strength almost always suffer massive physical trauma afterward. We're talking severe muscle tears, snapped ligaments, and even bones fracturing under the sheer strain of their own contracting muscles. There's also a major risk of a condition called rhabdomyolysis, where the skeletal muscle breaks down so violently that it floods the bloodstream with toxic cellular debris, which can easily lead to acute kidney injury. Add in the extreme cardiovascular strain, and it becomes pretty clear this is a dangerous break glass in case of emergency ripcord. It is absolutely not a superpower you can train for at the gym. All of this connects beautifully to a broader biological principle established by the physician Hans Selye, called the general adaptation syndrome. Selye modeled how we respond to stress in 3 distinct stages: alarm, resistance, and exhaustion. Hysterical strength is essentially the ultimate alarm phase, but if the body stays in this highly agitated fight-or-flight state for too long, it rapidly crashes right into that exhaustion phase. The immune system fails, organs take severe damage, and the body just breaks down. It shows exactly why our biology relentlessly prioritizes homeostasis, returning to a calm, balanced baseline state. Actually, living at 100% capacity would quite literally kill us. So as we wrap up this explainer, I really want to leave you with a provocative thought. You walk around every single day operating at just a fraction of your true physical potential. You have this incredibly powerful emergency reserve of raw explosive strength lying totally dormant inside your cells, protected by a brilliant neurological governor that just cares more about your long-term survival than your short-term output. It really makes you wonder, if the brakes were completely taken off, what is your body truly capable of that you just haven't discovered yet? Thanks so much for joining me on this deep dive into human biology. Keep wondering and keep exploring.